Okay, welcome to lecture 11.3. Okay, so now I'm going to talk about my paper with Charles Stewart. Um it's called something like The Value of Committee Seats in the House. I think that's it. Um, so here is what's going on, the history of this. So, two great scholars, Bullock and Sprague, um, said, people talk about the House of Representatives that some committee seats are more valuable than others. And, who knows if that's true? How could we get data on that? And they had a great idea. They said, well, let's just look at transfers on and off committees. They said, if you're leaving the post office committee for a seat on Ways and Means, revealed preference says you probably the rules are you could refuse. You can always say no. I don't want that. But you took it. It reveals that you actually prefer Ways and Means to Post Office Committee. And so Bullock and Sprague said, well, let's just get data on transfers. Look at every time there's been a new Congress. Look to see how many people left a committee, look to see where if they got seats on new committees, and treat that as transfers off the certain committee onto another committee. Gather all that data, and then they computed these measures, and they said for each committee, they looked at the total number of transfers onto a committee, and then divided by total number of transfers off the committee. He looked at that ratio, and the higher that ratio is, the more valuable is the committee, right? Presumably. Okay, great idea, and they got lots of citations, duly, but they should have. Now, then comes another great scholar, Mike Munger, and so, by the way, what I'm getting to, a little gossip here. So, I respect all those scholars, and maybe especially Mike Munger, my good buddy. But there's something. Sometimes I make fun of people in science or social science, especially. I call them paprika sprinklers, and they take someone else's work. It's like you're a great chef. You've got this great soup, and then some other chef says, need some paprika. Sprinkles a little paprika and says, oh, now I've improved the soup. Now my soup is better. And definitely you could say that about me and Charles Stewart. We were maybe you could call us paprika sprinklers on this. To less extent, but you may be able to do that also about Munger. Munger did this, sprinkled some paprika into the Bullock and Sprague's paper. But Munger had, regardless, if you only call it paprika, I mean, this was pretty insightful paprika that this guy sprinkled. What he did, he had this key insight, is that Bullock and Sprague, they only looked at the total number of transfers on and off a committee, and they didn't look at where they were transferring from and to. So, for instance, suppose you transfer off so it's well known, everyone hates the post office committee. No one wants to be on that committee. Suppose you transfer off the post office committee onto the ag committee. Well, you know, that gets you one, a transfer onto, but maybe that's really not saying that much about the popularity of the ag committee. But meanwhile, everyone thinks, Rules Committee, Appropriations Committee, Ways and Means, those are all really valuable. And suppose you have a case where someone transfers off of the Rules Committee onto the Ways and Means. Now, that's an indication that Ways and Means is really, really popular. So someone transferred off this popular committee, Rules, and onto some other. And so in some ways that should be more valuable than if the person transferred off, or more a bigger indication of the popularity of that committee than if the person transferred off the post office committee onto Ways and Means. And it's similar to case in sports. So if you just look at the won-loss records of teams, you say that often doesn't say how good the team is because someone may have had a very easy schedule. So, people in sports are like, oh, you also have to look at the strength of schedule. And I don't think Munger used those words, but he used that point is to say, look, what Bullock and Sprague did is ignoring the strength of schedule. And so he had a clever way, used some technology from social choice theory to say, look, can we? I think he did something about the top cycle set, and then something like a second top cycle set. I can't remember the exact terms he used, but he had a way of ranking committees by using that technology, not just transfers and not just the number of transfers on and off a committee, but also took account of which committees you transferred off of and which committees you transferred on to, as also indications how popular that committee is. So then, Charles Stewart and I just took Munger's results and his great idea, and we're going to sprinkle a little paprika on it. So Munger had this social choice idea, and we said, well, let's put in basically a econometric structural model to do basically Munger's idea. And then, so, some people may say, you may even get me to say, oh, yeah, our method's better but, it's only better in the sense of some chef that sprinkles a little paprika on someone else's soup. So I admit that's kind of what we're doing. We're another analogy would be we're standing on the shoulders of some great scholars, Munger and Bullock and Sprague. Okay, now here is the model. Okay, so eventually what we're going to do is we're going to get transfer data. And so we're going to see any given Congress, you may have something like 20 to 60 cases of some member who left some committee and went on to another. And so you can say, oh, this person transferred off this committee and onto this committee or these committees. Sometimes it's not one for one, by the way. Sometimes you may leave one committee and get 2 seats, or you may give up 2 seats and get one seat. Okay, so that's another wrinkle that we're going to have to look at. Now, when that happens, and here's maybe something to think about. Maybe it's a good dissertation chapter. We treated that data as if it were like a survey where you called up the member of Congress and said, suppose the person left Post Office and Agricultural Committee to go on to Ways and Means. And we treated it as if it was a surveyor calls up that member of Congress and said, hey, suppose you have the choice. A seat on both Post Office and Ag, or a seat on Ways and Means. Which would you prefer? Most would say Ways and Means, I think. But some may say, no, I'd prefer the double case, Post Office and Ag. But we treated all these transfers as if it were an answer to that question. Now, it's not clear that's really what's going on, that case really is, like a surveyor's question, because we totally ignore how that question came up, how the opportunity to transfer onto the Ways and Means Committee. So someone would say, well, we kind of have a sample selection problem. We're not, if someone transferred from Ag and Post Office onto Ways and Means, we really don't have the data of someone seeing an opportunity to go the other way. Okay, so you could criticize our method that we really aren't capturing exactly what's going on. We say it's as if it's like one of these surveys. Okay, to the extent that's true, our model is correct. It should give us accurate estimates, but maybe that assumption is not quite accurate. But I would say, look, just because we're spelling out the model, it makes it more transparent that maybe we're violating some assumptions. The other models were not as explicit in writing out a model, so I might say some of those same criticisms could be leveled at them too. Okay, so that's a small criticism of our paper, maybe a couple small criticisms, and maybe a weak defense. Okay, nevertheless, here's what we did. Okay, first we assume that if we see some legislator and um, that legislator is involved in a transfer, we assume that person I's valuation of committee J equals, okay, we'll define it as Vij, and then we'll assume that it equals V sub j plus epsilon j superscript I. Assume that epsilon ij is distributed normal 0 sigma squared. Okay. Then, okay, given that, so this is I's valuation committee J. Now, suppose that person I, committee Congressman I, left committee J or left committee K for J. So we would say this is as if a surveyor asked him, "What do you prefer, committee J or committee K?" And the person said, "Oh, committee J." So we'll say, "I prefers J over K if and only if VJ." And by the way, notice that VJ, so that's like the average committee valuation. Notice it doesn't have a superscript for person I. So that's just the J for committee J. So I prefers J over K if and only if Vij plus epsilon Ji is greater than VK, sorry, plus epsilon Ki. Okay. So this is true if and only if epsilon K I minus epsilon I J is less than or equal to Vj minus Vk. Okay. Now we assume all these epsilons are independent of each other. They all have the same sigma squared. So now a variance of epsilon Ki minus epsilon Ji. So the variance of the sum is the sum of the variances if they're independent. Okay, so this is going to equal just sigma squared, variance of epsilon ik, plus sigma squared, the variance of epsilon ij. So equals 2 sigma squared. So now the probability I chooses J instead of K. Okay, so we say this is like it's a surveyor's question. It's just going to be probability that is true. Probability that is true, and that is just going to equal phi. So divide both sides by the square root of the variance. So square root of 2 times sigma. So that all is going to equal Vj minus Vk divided by sigma times square root of 2. Okay. So that's where we're going. We're going to build a likelihood function. We're going to have all these cases where we see a transfer, and we're going to say the probability that the transfer went the way it did as opposed to the opposite way. Okay, and there'll be these probability terms like that. Okay, where do I want to know next? next. Okay, now if I gains a seat on J, on committee J, and didn't lose any other seats. So the answer is that the person prefers that to nothing. So so he had like his normal portfolio plus nothing else, but then all of a sudden he gains J, so he must have preferred that J to the no seat, to a non-seat. So we're going to say the value of a non-seat is 0. So that's the base utility of not being on any committee. Of base utility is 0. So if I gains a seat on J, the probability I prefers J to no seat, that just equals probability V sub j plus epsilon ij, that's greater than or equals 0, and that equals probability negative ji less than or equal to vj. Okay, the standard deviation of epsilon ij is just sigma. Divide both sides by sigma, and that's just going to be phi of vj divided by sigma. Okay. Now, now I'm going to write some data, some sample data, and write a likelihood function. Okay. Suppose there are 3 committees, 1, 2, and 3. Suppose a legislator transferred from 1 to 2. Okay, transferred from committee 1 to 2. Another legislator transferred from 2 to 3. From committee 2 to committee 3. Another legislator transferred from 3 to 1. And then a fourth legislator, gained a seat on 2. And so the idea is going to be a term like this. That person will say preferred a seat on 2 over nothing. So let's write the probability of observing all those observations. Now remember, we're treating it as if it's like a surveyor has said, hey, you legislator, you prefer 1 or 2, committee 1 or 2. Well, he transferred from 1 to 2, so we're saying he preferred 2 over 1. So we're going to write the probability that this person prefers committee 2 over 1, and that is going to be, where did I write it? It's going to be a term like this. So v sub 2 minus v sub 1. Okay. We'll have the probability that the person preferred 3 over 2, okay, as opposed to the opposite, and the probability the person preferred 1 over 3 as opposed to the opposite. Okay, so let's write out that likelihood function. So this is just going to equal L, and this is our parameters are going to be V1, V2, V3 in sigma equals the probability that some legislator I prefers 2 over 1, and that probability is just going to be phi of V2 minus V1 divided by sigma times the probability that other legislator preferred 3 over 2, V3 minus V2. Oh, excuse me, that's going to be times square root of 2 sigma times square root of 2 sigma times phi of the 5v3, so preferred 1 over 3. So v1 minus v3 divided by square root of 2 times sigma times the probability that one person preferred committee 2 over nothing, and that's just going to be v2 over sigma. Okay. All right. So now we've got a likelihood function. Okay. The idea is we got to maximize that, pick the v's and the sigmas so that we maximize that. By the way, we're going to have an identification problem. If we multiply, so remember the v's are parameters, the v sub j's. So if we multiply all the v sub j's, all of them by some constant delta, multiply sigma by the same delta, we're going to get the likelihood function will not change. So we're going to have to set sigma equal to 1. All right, so make that 1. Okay, so that's the likelihood function we're going to estimate. Okay, let me tell you one more problem. Another possible identification problem. Suppose we didn't have that last observation. Okay, we've got all these v's, and suppose that we added a delta to all the v's. Okay, so we'd have v2 plus delta, and then it's minus v1. That's v1 minus delta. Okay, same thing here, v3 plus delta minus v2 minus delta. Turns out the deltas are going to cancel each other out. Okay, so that's a problem. Without this last observation, if we added a constant, so if we added a constant to all the v's, we're not going to change the likelihood. Okay, but the great thing is we have this one observation. If we add a delta here, okay, all the deltas in these terms cancel out, but they don't in this one. Okay, because of this last observation, adding delta to all the v's will change the likelihood function. So once we have this last observation, everything is identified. Okay. Now you might notice the key is you got to have at least one observation where the transfer is not 1-to-1. Okay. More specific, if they were all 1-to-1 or all 2 for 2 or 3 for 3, it's got to be, you have to have a case where someone left K committees, transferred on to M committees, and M and K are not the same. For at least one observation, that's not the same. If you have that, then you can identify everything. Okay. So given that, that's identified. Okay. Now, let me tell you what we're going to do. Okay. The next week in the next session. I'm going to tell you how we can use a probit to estimate this. So one way to estimate it would be just, program this into R and say, R, pick the V's that maximize this. Okay. Now I'm going to show you how this is kind of like a probit likelihood function. Okay. So that's what I want you to do. First, here's a question to ponder for next week. Okay. It's not, you don't have a written assignment, but think about this. Suppose that you write down a probit likelihood function, okay, and then write this likelihood function and then say, wait, how could I make them the same? Okay. And one thing, you say, well, okay, look, we're going to create some clever independent variables. And then in the probit likelihood function, we have beta 0 plus beta 1, x1 plus beta 2, x2, and so on. So, well, we're going to make it so that these betas correspond to the v's. So we're going to tell our stat package, run this probit. Okay, we're going to create some clever ways to write independent variables. And then we're going to recover the betas, and then we're going to show how the betas equal the v's. Beta 1 equals v1, beta 2 equals v2. Okay, that's where we're going. Okay, now I'm not going to tell you all the things to do, but I'm going to show you another hint about how you might want to code the independent variables to get this. So notice that we have 4 observations, and so I'm going to write 4 data for 4 observations. Okay, I've done 4 dots here. Now, and I'm going to create 3 independent variables. Let me give you a hint. And what I'm going to do is these independent variables are going to correspond, they're going to be a series of ones and negative ones, depending on whether we have a positive v2 or negative. Positive v sub j or negative v sub j, or a v sub j at all. Notice that we don't even have a v sub 3 in this term. So what I'm going to do is I'm going to make x1 in that first case negative 1, because v1 is negative 1. 2, I'm going to make positive 1, and x3, v3 doesn't show up, so I'm just going to make x3 0. For this one, I'm going to make x3 1. I'm going to make x2 negative 1, and v1 doesn't show up, so I'm going to make x1 0. Here I'm going to make 1 positive 1, 3 negative 1, and then x2 0. And then the last one, I'm going to have x2 equals 1, and the other's 0. Okay, now, those look right. Those look like we're going there. Okay, what if we did a probit on, so these are the independent variables. Okay, run the probit. Would we get estimates of these? Well, not quite, and the problem is we have these square root of 2 here, square root of 2, square root of 2 here, we only have 1 there. But what we could do is just transform all these independent variables. Just divide by square root of 2 here, square root of 2 here, square root of 2 here, square root of 2, square root of 2, keep that 1. Okay, so now, here's where we're going. Okay, this is what Charles and I were thinking about when we did this. Okay, it looks like if we just create, if this is our likelihood function, we create this data, and then we just say, hey, stata, whatever, run a probit. Here's your independent variables, okay? It should recover betas that equal the v's, okay? But not quite, okay? Now I want you to think about, over the next week, think about what a probit likelihood function looks like. Think, why does this look kind of like a probit, but not quite? And then think, how would you change the probit likelihood function that you wrote to make it look exactly like this? Okay. So here's what you're going to do. And we thought, okay, there's one extra little step. So if these are the independent variables that you've created, and you tell stata, run probit, you got to do one little more trick. Okay, I'll talk about, hopefully, see if you can come up with your own. And then you're ready. Okay, that's what I thought, at least. And I remember going to Charles Stewart's office. So he had the data. We're about to run it on SAS, actually. And Charles is sitting there. We've typed in these independent variables. And Charles is just about to type in probit. And Charles says, what's the dependent variable? And I thought, I didn't think of that. Okay. That's part of your homework. Think about what would you need to use as a dependent variable to make your probit likelihood function look like this likelihood function. Okay, so I'll leave it there. So that's going to be the brain teaser. Hopefully you got a week to think about that. I didn't assign homework, but this is a problem you can do, an optional homework problem that I hope you might do on your own. So for next session, be sure to read uh, my paper with Charles Stewart, and also want to do the Levitt paper on how do senators vote. And the idea for next week is just a couple cases where we have a likelihood function, but it turns out you can transform the likelihood function, do some special ways, and you can estimate it with some very simple methods. In my and Charles' cases, with the probit. With the Levitt case, you can actually estimate his likelihood function with a regression. Okay, there's going to be some calling it regression and probit tricks. Okay, so that is for next week. Once you read those papers, think about that, and I will see you then.